It's entirely unpredictable. It could happen tomorrow or even during this broadcast, and when it does, it could shine like a second sun in the sky. Recently, the James Webb Space Telescope detected a surprising 250% increase in the brightness of a red supergiant star known as Betelgeuse, located at the shoulder of the Orion constellation. This unexpected flare has ignited excitement, with some speculating that Betelgeuse may be on the brink of a supernova explosion. However, the timing remains uncertain. Join us as we dive into the mysteries surrounding this celestial giant, Betelgeuse. While the star's name might not be as widely recognized as others, you've likely admired its brilliance, glowing brightly in the night sky at the shoulder of Orion. If Betelgeuse were positioned at the center of our solar system, its outer surface would extend beyond the orbit of Jupiter. This massive star continues to captivate astronomers, and its behavior is anything but ordinary. Unlike many other stars, Betelgeuse exhibits significant fluctuations in brightness due to its status as a semi-regular variable star. Its light ebbs and flows, signaling that it is nearing the end of its life and could eventually collapse into a supernova. In recent years, Betelgeuse's peculiar behavior has attracted more attention. On May 20, 2023, its brightness spiked by 142%, followed by a later increase of 150%. Betelgeuse now ranks as the 7th brightest star in the night sky, moving up from its usual position as the 10th brightest. From the southern hemisphere, it's easily visible, especially around the Orion constellation. Dr. Sarah Webb, an astrophysicist at Swindon College of Technology in Australia, emphasizes the significance of Betelgeuse's behavior. The star offers a rare opportunity to observe the final stages of a massive star's life, providing insights into the behavior of red giants just before they explode as supernovae. When Betelgeuse finally detonates, it could become incredibly bright, outshining the moon for a week, potentially casting shadows at night. This prospect has both amateur astronomers and professional scientists eagerly awaiting the event. Heidi Morris, a researcher at Los Alamos National Laboratory and president of the Padaro Stargazers and Astronomy Club, notes that interest in Betelgeuse's brightness fluctuations has been ongoing for decades, with many ancient cultures also documenting this phenomenon. Betelgeuse's brightness cycle, which typically spans 400 days, has recently shortened to around 130 days, leading scientists to explore its behavior in more detail. This rapid change presents an exciting opportunity to study the late stages of a star's life, and may offer key insights into how red supergiants evolve before they explode. Betelgeuse's unusual behavior dates back to 2019 when it dramatically ejected part of its outer atmosphere. These changes in brightness have raised questions about whether it might soon explode as a supernova. According to a paper by Dr. Andrea Dupree and researchers from Harvard and the University of California, Berkeley, it could take another 5 to 10 years for Betelgeuse to return to its typical 400-day brightness cycle, following the recent dimming. Despite this erratic behavior, Betelgeuse remains a massive red supergiant undergoing rapid evolution. As it depletes its fuel, its core will eventually collapse under its enormous mass, leading to a supernova explosion that could outshine entire galaxies. However, predicting the exact timing of this event is challenging, as Dr. Grover, an academic associate in astronomy at the University of Portsmouth, points out. The process of stellar evolution is complex, and there's limited historical data on supernovae, making it difficult to predict when Betelgeuse will explode. Currently, Betelgeuse is undergoing fusion processes, steadily progressing through elements like helium, carbon, oxygen, silicon, and eventually iron. As a red supergiant, it fuses helium into carbon at its core, a process that can take millennia. Eventually, the star will begin to fuse heavier elements until it can no longer sustain fusion reactions, causing its core to collapse. This will result in a supernova explosion, potentially forming either a black hole or a neutron star. While some theorize that Betelgeuse could explode in the near future, historical data suggests that it may take much longer. NASA estimates that Betelgeuse may not go supernova for another 100,000 years, offering reassurance that the explosion is unlikely to occur within our lifetimes. Despite the uncertainty, Betelgeuse's behavior continues to fascinate astronomers, driving advancements in our understanding of stellar evolution. Dr. Sarah Webb reminds us to remain open to the possibilities of what may happen, even if the likelihood of witnessing Betelgeuse's explosion in our lifetime is slim. By monitoring its changes, scientists hope to unlock new discoveries about the cosmos. However, it's important to remember that our observations of Betelgeuse are essentially glimpses into the past. The light we see from this star is over 600 years old, meaning Betelgeuse could have already exploded, and we wouldn't know about it yet. While this possibility exists, it's far from certain. History has shown that our assumptions in cosmology can be overturned. In 1987, for example, astronomers believed only red supergiants could explode as supernovae. However, that year, a massive blue star in another galaxy detonated, surprising the scientific community. This serves as a reminder that there is still much to learn about the universe, and Betelgeuse's eventual explosion could challenge our current understanding of stellar life cycles. The consideration of individual cosmic events has expanded, especially with the impending explosion of a nearby star that could provide insight into celestial phenomena for years to come. One such star, Betelgeuse, is nearing the end of its life cycle and is destined to eventually explode into a supernova, transforming into either a neutron star or a black hole, depending on the material left after the explosion. However, many astrophysicists caution against immediately attributing the recent dimming of Betelgeuse to a supernova. Instead, they suggest that more common phenomena, such as convective cell activity or the presence of a dust cloud, might be the cause. A research team led by astrophysicist Miguel Montargis from the Paris Observatory used high-resolution images captured by the extremely large telescope in Chile's Atacama Desert to investigate the unusual dimming. Their images, taken between January 2019 and March 2020, helped to uncover the cause of the dimming event. The team concluded that a combination of convective cell activity and the presence of a dust cloud was likely responsible. The pictures clearly revealed a significant reduction in brightness in the lower left section of Betelgeuse, while the rest of the star remained relatively stable during the observation period. This led to the hypothesis that a massive eruption on Betelgeuse's surface had expelled an extraordinary amount of mass, far beyond typical coronal mass ejections seen in stars like our Sun. Researchers believe this eruption could have been triggered by a gas plume rising from deep within Betelgeuse, amplified by its regular pulsation cycle. While the exact cause remains unclear, the star's recovery from the dramatic dimming has been closely monitored. Subsequent observations and computer simulations have confirmed that a dust haze, likely caused by a massive ejection on the star's surface, was the primary cause. More than 10,000 simulations supported this conclusion, suggesting that the phenomenon was caused by an unusual mass expulsion event. Astrophysicists like Meredith Joyce from the Space Telescope Science Institute in Baltimore have expressed confidence in this explanation, emphasizing the need for continued observation and research to unravel the complexities of celestial phenomena. Betelgeuse, known for its periodic dimming every 400 days, was particularly striking in 2019 when its brightness dropped by a remarkable 2/3, a change that was visible even to the naked eye. The cause was traced to a massive eruption that expelled a substantial part of the star's visible surface, an event that disturbed Betelgeuse's internal dynamics. This mass ejection, around 400 billion times larger than a typical coronal mass ejection, disrupted the star's internal forces, similar to the effect of removing a piece from a spinning object, causing violent fluctuations inside the star. Although Betelgeuse's core and stability are still recovering, the star continues to exhibit unusual behavior, such as internal pulsations. These observations provide valuable insights into how red giants shed mass as they approach the end of their life cycles before potentially exploding as supernovae. However, astrophysicist Andrea Dupree cautions that Betelgeuse's recent behavior doesn't necessarily indicate an impending supernova. She has been gathering data from NASA's Hubble Space Telescope and other observatories to better understand the star's unusual disruption. The massive release of mass from Betelgeuse's surface, which interrupted its normal 400-day pulsation cycle, demonstrated the severity of the eruption. While the outer layers have returned to their usual state, the star's surface continues to fluctuate as it recovers, akin to an unstable jelly dessert. This event's significance lies in its rarity. Never before have astronomers witnessed such a large portion of a star's visible surface being blown away. It suggests that surface mass ejections could be significantly different from the coronal mass ejections observed in stars like our Sun. Human fascination with Betelgeuse spans millennia, captivating minds across cultures and igniting enduring curiosity about celestial phenomena. Known as insect juice in Arabic, Betelgeuse's changing brightness has intrigued civilizations for over 2,000 years, with ancient Egyptians and Greeks observing its variability. In Egyptian cosmology, the star was linked with the god Osiris, the ruler of the underworld, and its Arabic name, meaning the giant shoulder, reflects its association with the Orion constellation. Interestingly, ancient records suggest that the star may not have always appeared as the red hue we see today. Native Australians also had profound knowledge of Betelgeuse's brightness changes, passing down oral traditions that offer valuable insights into the history of stargazing and the remarkable observational skills of these ancient cultures. The discovery of Betelgeuse's variability challenged the long-held belief in the constancy of stars, leading to the rise of astronomy as a scientific field. Since then, Betelgeuse has been classified as a semi-regular variable star with a longer pulsation cycle than most stars, further contributing to its intrigue. Despite centuries of study, there remains much to learn about Betelgeuse and the vast universe it inhabits. Its story serves as a reminder of the immense complexity of the cosmos and the ongoing exploration of its mysteries. Shocks may be on the horizon as we study the behavior of stars like insect juice, which provides a unique opportunity to understand cosmic phenomena, even in the absence of a massive explosion. The current state of insect juice is fascinating, as its fluctuating brightness offers insights into the underlying physics of stars. Right now, it's significantly brighter than expected due to its normal 12-day cycle. While there's hope that it will eventually return to this cycle, it is currently struggling to do so. Recent observations suggest that insect juice might be entering the final stages of its core carbon-burning phase. In this phase, carbon is transformed into heavier elements such as oxygen and magnesium. If this is true, experts predict that the star could experience a core collapse, leading to a supernova explosion in the next few centuries. However, the exact phase of insect juice's evolution is still difficult to pinpoint, and uncertainties remain about whether a supernova will happen within our lifetimes. The carbon-burning stage could last up to 1,000 years, and the study suggesting an imminent explosion is not yet published. Nevertheless, the prospect of insect juice going supernova is exciting, as it would be a once-in-a-lifetime event visible even during the day. When it occurs, the initial signs of the explosion will be subtle but unmistakable. Neutrinos will sweep across Earth, and high-energy photons will escape from the expanding cloud of stellar debris. Insect juice will gradually grow brighter in the night sky, possibly reaching 10,000 to 100,000 times its usual brightness within just a few weeks. This display will amaze anyone fortunate enough to witness it, marking a monumental event in cosmic history. The remnants of the explosion could shine as brightly as a quarter or half of a full moon concentrated into a single point of light. Remarkably, this glow could be visible during the day, casting dramatic shadows at night. Predictions suggest it could be 15 to 25 times brighter than Venus, the second brightest object in the night sky. The spectacle of insect juice's supernova would last for about 100 days, offering astronomers a rare chance to study the aftermath in detail. Fortunately, insect juice's supernova would not pose any threat to Earth, as it is far enough away. Telescopes would allow us to observe the event for an extended period without harm. However, such a dramatic occurrence would undoubtedly draw attention, and it's likely that the death of insect juice would stir public interest in astronomy, reigniting fascination with the stars on a broad scale. Insect juice is not the only red supergiant in our galaxy. Other stars like it could also explode in the future. The Milky Way is expected to experience a supernova roughly every 100 years, though we haven't seen one in the last 400 years. However, evidence of past explosions suggests that we are overdue for such an event. It's only a matter of time before another star puts on a spectacular show for the universe to witness. Insect juice's history is marked by notable events, including its mysterious dimming in the fall of 2019. This unexpected drop in brightness puzzled astronomers and sparked speculation about a potential supernova. While insect juice's brightness returned to normal by April 2020, the cause of its fading remained unclear until further observations provided answers. Skywatchers can easily spot insect juice from their backyards, providing valuable opportunities for research. However, to gain a deeper understanding of the star and its massive changes, astronomers rely on observatories like Hubble. The intrigue surrounding insect juice's dimming and possible explosion continues to captivate the scientific community.